data structures using C. Implementation of circular linked list. In this lecture, first of all, you will learn the algorithm to implement a circular linked list and write the related functions like insert a node, delete the first node, and to print the contents of a circular list. First of all, let us try to understand what a circular list is. Here you have got a pictorial representation of the circular list. We have already studied linked list. So linked list in which the rear is linked to the front, the head of the list is called the circular list. As you see here, you've got a set of nodes here, 5 nodes are there, first, second, third, etc. And the last, what is called the rear node, is linked to the front node. So therefore, it becomes a circular linked list. Circular linked list. So now coming back, the representation of the node of circular linked list like any other list node. Here you have got number and a pointer to the next. So we declare therefore a new data type called circular list node, which contains a number as the data item and a link to the next, a pointer to the next node is of the circular list type. So we have created here as a new data type, as we have done many times in the case of tree and queue, etc. and linked list. So we call this one therefore circular list node. Then we can create variables now. Now we are creating a pointer called node of the type circular list node. And here we allocate memory using malloc of the circular list type. Always note there should be a pointer here, asterisk, and size of circular list node. Then only we assign values. So node arrow number is equal to 30. I assign 30 to this number variable here, variable number, and null to the next pointer. So this is how we do. So then we will write now, for example, here we have got a pictorial representation of this. Node contains 30 and it points to null. It doesn't point to any other node. Now here we write a function as we have done earlier. So we have done make polynode, make list node, make queue node. Now we are making circular list node. Almost the code is almost the same, only some names are different. For example, we create a local variable called node of the circular listed node type. Then allocate memory, assign number, null, and return node. This node returns the starting address or address of this list node which contains number and points to null. For example, therefore, we are creating a node pointer. We are assigning 80, making use of this function node or new node is equal to make circular list node. Now, as you see, this node contains 80 and it points to null. This is the function. And this variable node contains the address of this node. So that is what we are going to use when we do insert node into a circular list. So with that, let us come to the algorithm for making a circular list. So here again, the same graphical representation. As you see, there are two variables here, front and the rear. So this is the regular linked list. It is the end of the linked list. What we have done is we are attaching rear next to front, or in programming we are going to say rear next is equal to front. That means you put the address of front in that pointer of next pointer of rear. That's how we are creating a circular linked list. So what do we do therefore in our programming? So we are going to program like this. We are going to create two global variables, front and rear, to represent the front of my circular list and the rear of the circular list. And in a function, we are going to assign null to each of these. We will write a function called init circular list or circular linked list, whatever it is. And then we are going to make this equal to null. Or you could do it at as a global variable. After declaring this, you could make it null, but it's better to write a separate function to show that we are initializing these front and rear to null. So that is what we are going to do. Now let us come to the creation of the circular linked list. Case 1. Always case 1 means there is no list. So how do we know that there is no list, circular list? So check whether the rear of the circular list is null. So if the rear is null and also the front is null, that means there is no circular list. So that is what we are going to do. So if the rear is null, make the incoming node front and rear of the circular list. That is what is done here. So we are creating a new node, for example, out of 30. Then I ask if rear is equal to null, front equal to rear is equal to new node. That means I am assigning the address of new node to the front and rear since there is only one node. Then I have to connect now. In that same function, you will be connecting rear to the front. So return. All right. So here it is. So the new node which contains 30 is points to front and the rear, and of course afterwards we'll link this rear to the front. So that is done in the function I will be explaining to you. Case 2. There is a circular list, linked list is there. So we have to attach the new node. How shall we attach? So what we will do is, to make this simpler, we will attach the new node at the end of the list. That is at the rear of the circular list. So that is what we are going to do. So we don't have to traverse because we already have the pointer to the rear. So rear next becomes therefore the new node. New node is attached to rear next. So that is what we are going to do. Let us see. So how do we do? Then, so what we do is make the incoming node the rear of the list. How to do that? So attach the incoming node to rear next. So you say rear next. At the moment is rear next is pointing to front. So you remove that. You may say rear next is equal to new node. So I'm attaching new node at the end of rear. Then what happens? Now you have to make that rear as the new node. The new node has to be made as the rear. That is what we are doing. So rear next is equal to new node, and then sorry. Then I'm making the rear. I'm putting the address of new node and making it rear. Making it rear. That is, make the new node the rear of the list, and then I will show you in the program. And then you link the rear to the front. How do you link? You put the address of the front to rear next. That means rear next is linked to the front. This way the link is made and you get the circular linked list. So for example, a graphical representation of the same thing. So I have a list here containing 4 numbers. This is the rear at the moment. Rear next points to the front at the moment. So what do we do? Therefore, I have created a new node. I attach it to, so new node which contains 85, I have attached it to rear. So new node next is equal to, what is the rear? Rear next is equal to new node. That is what we have done. Then you say, now this is rear at the moment, so we have to make this rear. So that is what you, when you say rear is equal to new node, now rear comes, this becomes the rear. Earlier this was the rear, now this becomes the rear. Now you have to link rear with the front. So that is done. Therefore, rear next is equal to front. In other words, you put the address of front to the near rear next. That is what is happening. This is severed now. Now rear next points to the front. This way we have linked the new node to the front, and we have inserted the new node at the end, and at the same time we have linked it to the front. So this becomes my circular list. So this is the program which does all that. So insert circular list node number. I create a new node out of that number and ask if rear is equal to null. I say front and rear is equal to new node. In other words, the new node becomes the front and the rear of my circular list. Then in capacity. Now there is only one node. I'm using one more variable for capacity. I'll explain to you later. So I say capacity because it is a global variable. I assign 0 to that in my as a global variable. Now I make it capacity is equal to 1. That means there is one node in my list, and whenever I add extra nodes, I am going to increment the value of capacity by 1, and whenever I delete the front node, I am going to decrement the value of capacity. So then this is done. Otherwise what I am going to do, you have the address of the rear. So rear next is equal to new. You create a new node, you attach to the rear next as I showed you just now, then make that new node the rear and increment the capacity because you have added one extra node. And here, once you have added that extra node, you link that rear to the front. Therefore, assign the address of front to rear next as I've shown you here. So rear next becomes the front. So that is what is done here. This is the function to insert a circular list node. So with that we come to the deletion of the first node in my circular list. So we have got a circular list with the 4 numbers. I want to delete the first node. That means I have to remove this node. How do I do that? So that means this node has to be removed. Now rear next points to this. It has to point to this node. So how do we do that? So first we say we assign front to a variable called current. Then this becomes current therefore. Then what to do? I want this number. So therefore you assign this number, you say number is equal to front number or current number. So that 20 will go into a variable called number. So I have removed this number because I am going to return this number. Then now I have to link rear next to current next. So that is what we are going to. Front is equal to, therefore front is equal to current next. That means front is going to point to this node because this is going to be the front. This is the rear. Rear remains as it is. So because earlier this was the front, now front points to the next node. So current next. So that is done. Now rear therefore has to be linked to this. So therefore rear next is equal to front. So this is linked. And I have to remove this. I have removed all these connections. So that means I have to free this node. That is what is done here. Free current means this is removed, completely removed. So that current, the first node of my earlier circular list is removed and we get a circular list with 3 numbers. Similarly, you can remove the next one, at the end only one will be remaining. So that we will look into when we write the function. So here is the function, delete first node. So as I said here, if the capacity is equal to 0, that means there is no node. So then what you do is assign null to front and rear and return. So you don't have to go further. So give a message saying that circular list is empty. Otherwise, if there is only one node, front and rear are going to be the same. The addresses are going to be the same. So if front is equal to rear, then what you do? You take that number from the front, you release the front, make capacity is equal to 0 because there is no node at all. Then you assign null to front and rear. That means there is no list existing. And you return the number because you have removed that number, last number, which was present in the circular list. And otherwise what you do, otherwise as I have shown you in this, so otherwise shown like this. So what you have to do is make current, put the address of front into current. Then you say you get that number which is present on front. Then you make front is equal to current next that I showed you. And rear, make that rear next or connect that rear as you shown here. This rear next is equal to front as it is here. You are doing that and decrement the capacity because you have removed one node. Decrement the capacity, free the current and return number. So this is the function to delete first node in circular list. We have to write one more function later. I am not going to do this time. So to delete any node in the circular list, that's also possible. We will do that. So this is how we do. And here is the complete program, showing part of the program. I've shown you the functions. So here we declare the new data type called circular list node. Here I have declared circular list node front and rear as 2 pointers here, and capacity is equal to 0. Here I have got the prototypes of various functions: make circular list node, insert circular list node, delete list node, delete first node, print circular list, menu, and init circular list. In this function we are going to make front and rear equal to null. So that is the first function I'm going to call in my main program. Then we have got. So thank you.